Okay, so let's start. Yeah, we are Chronicle, and this is the Oracle workshop. So how do you guys can use our oracles? First, a little bit about me. So I'm Pascal, or also Merkleplant. You may know me from this white guy NFT thing. Otherwise, everything Merkleplant related with my profile. So if you want to reach out after this workshop, don't hesitate to write me on Twitter or email or something like this. And yeah, then the questions, who are we? Because probably you didn't hear the name Chronicle so often, but actually we are along since a very long time. Because, yeah, actually since 2017, we are the first ever Oracle on Ethereum and the longest running Oracle. Why do you probably not know about us so well? Because up until now we had the very sexy name of MakerDAO Oracle Core Unit. So we are the exclusive Oracle for MakerDAO. We have just very few selective other customers, but MakerDAO is like the main part. And yeah, yet, because this is going to change in around 3 weeks on permissionless in New York, we are going to launch for public availability. And this is why we want to make sure that as many people as possible know how to read our oracles and also kind of know how we work. Here are some keywords about things that we pay a lot of attention about, why we designed our new Oracle version, which we just released around about 3 weeks ago. The first one is verifiability. So, I mean, oracles in the end is always something with trust, but you should verify it as much as possible. And we have the property that in the end, someone at some point in time needs to fetch data from some source, price data like Coinbase, Kraken, something like this. Then there's this big black hole of you select the price, there's some consensus finding, and in the end something is pushed on chain. What differentiates us from other Oracle providers is, in our case, it's actually not a black hole. Every signature that's created inside of this peer-to-peer network, every step that's happening, every computation is cryptographically verifiable, and not just for like the highly technical people who know how to listen to the peer-to-peer network. You can actually do this on our website, which is launching currently. We are also community-powered. What does this mean? So you need to have, in oracles, you need to have this set of validators or fields, as different terms are there floating around. And in our case, our fields, our validators, are systems, are entities that are heavily invested in the ecosystem. So for example, who are our fields? For example, we have EtherScan on board, we have DYDX, ZeroX, Gnosis, the Gnosis DAO, MakerDAO. So all protocols who stake their reputation, and if they would act maliciously, they would not use any, like there's no, they would not lose any stake, which, like any monetary stake, which may not be worth as much as the malicious attack could be worth for them, but they actually risk their main business. Like if we prove, and we could prove, if EtherScan acts maliciously in our Oracle system, they use basically being the monopoly on block explorers. So this is, in what we think, a lot more powerful a lot more powerful system of validators than just companies who just being a validator for this one Oracle system, and if you're going to fire them next month and they know this, well, that's all their incentive, like just blew away for being honest. We're also pretty decentralized. Like if you know about MakerDAO, MakerDAO is generally, at least in the public opinion, like always said to be one of the more decentralized projects, the longest running DAO. And we are part of MakerDAO since the very beginning, otherwise MakerDAO would not be possible. A nice feature that we have is also that our backend is totally blockchain agnostic. So actually, this price data that is being fetched somewhere, calculated, and then signed, all the fields do not know that this data in the end lands on Ethereum. There's nothing Ethereum specific about this data and nothing specific about in the code. The only thing that we need to do on-chain is basically verify the signatures. And we can do this on any blockchain. We currently only have EVM contracts for this, but it's not so much work to like launch on non-EVM blockchains. And we are also cost efficient. What does this mean? What does this mean? Everyone knows what this means. But one problem that oracles have is that we basically need to update the price a lot of times. Like we need to update it frequently, as often as possible. And there are basically two different ways how you can do it. You can do it via a push model, or you can do it via a pull model. Push model means someone else is pushing the data for you on the chain. In our case, like us or this Etherscan, DYDX entities. Or you can make the user do it, which in the end means, okay, you shift all the cost that you actually have, that your business actually have, shifted towards the user. Of course, it always takes time for degens in crypto to notice that, but next time when gas will be 7K, they will notice if their other transactions suddenly increased in price a lot because they are the badasses who have to update the Oracle. And we are very cost efficient, which, just to name some numbers, if you're deep enough in the technology, so our Oracle to update it costs 60K gas. 20K gas is any Ethereum transaction. We have to write 2 storage slots. This has to do, every Oracle has to do this. There's no way around. This in itself costs 40K gas. So we nearly hit the theoretical minimum of being as cost efficient as possible with just 60K gas. And at the same time, everything cryptographically verified via so-called Schnorr signatures. And now a small overview about our whole system. How does it work? So on the left side here, we have the sources. This is what we call sources. It's Coinbase, Kraken. It may also be on-chain, like Uniswap, Balancer, Curve. And this is basically where the price is created, right? Because there are traders, and this is where the price is coming from. Then we have our peer-to-peer network of feeds. These are the entities that you trust anyway already. Like in Fewer, you probably use MetaMask, so you trust in Fewer already quite a lot. You probably have a Gnosis safe, so you trust Gnosis already quite a lot. I bet if you do a new transaction, the first thing you do is go to Etherscan and check exactly what does the transaction do. So you trust Etherscan already a lot. In our feed network, there are not so many new entities that you don't trust already anyway. So our increase of trust that you need to have to use us is pretty low compared to many other competitors. And what does happen here? So everyone fetches prices from a lot of different exchanges and otherwise aggregators or whatever. They'll all exchange the prices continuously, everything cryptographically verified. You can verify this yourself. You can listen to the peer-to-peer network the whole time. And one distinguished feature between us and other providers is also everyone can push the price on-chain. It's not us who does the pushing the price on-chain. You just need to listen to the peer-to-peer network. At some point, or basically continuously, you get price data that all the feeds found a consensus on, that this is the right price and signed it properly, and you can be the one who pushed it on-chain. Of course, you don't have to, but you could be, and this is a very powerful feature. And if you think about MEV problems, front vulnerability problems or something, if you want to have an Oracle update exactly at the moment you want to, just listen to our peer-to-peer network, take a private mempool where you have some deterministic transaction ordering, and put the transaction exactly where you want. And this is also where we see that we are totally smart, chain agnostic, because everything that's happening here on the smart contract level is just verify the signature, verify that it's from enough feeds, and we update the price. Okay, but in the end, you're not so much here. Yeah, question. Perfect. Okay, just to repeat this for the recording, the question was who pushes the data on-chain? And that's a quite interesting question. So we are Chronicle, the Oracle core unit. We actually don't run any of the software. We are just software producers, open source software producers. All of the software is run by different entities. And it's basically incentivized to push the data by whoever uses the data. And this is, for example, at the moment, it's mostly MakerDAO, but also DeFi Saver uses part of our Oracle. So they are incentivized to push the data, and they also do it. And this was proven that they do it at the highest gas spikes that we saw since 2017. And we can further incentivize this if we want to by having some more MEV incentivization, which is built into the smart contract already, just not activated. But of course, we could also run them ourselves. And if you want to make really sure, if you're a big protocol and you want to make really sure that your price frequency is the frequency that you want, and you don't want to trust us to push the price in that frequency, if you're big enough, it's worth yourself to do this because all your customers are depending on it. So yeah, currently mostly MakerDAO. In the future, we will incentivize it further. Yeah, but as I said, you're not really here to know so much about the backend stuff, I guess. You're mostly smart contract engineers, more or less, or enthusiasts, and you want to use our oracles. Okay, this is a little bit small. First of all, you can scan this QR code. I hope that works. Otherwise, down here is the link. This is our interface. You see it's not very long. It's basically as simple as possible to make it as hard as possible for users to, well, do anything wanky with it. Can you kind of see what's written here, or should I try to increase it? I try to increase it. Yeah. Ah, okay, it does not work to increase it. Okay, so what do we have here? We have one function called WAT, the WAT. This is basically just the Oracle identifier. If you want to have a BTC price in USD, the WAT function will return you BTC/USD. It's the asset. Then we have the read function. You may be wondering what that does. It reads the Oracle. It returns you an unsigned integer. That's the price. We always use 18 decimals. This is a constant that we have used since ever. It's the default precision on Ethereum. So it returns you, the read function returns you the current price. But you have a problem there. What if, for any kind of reason, our Oracle does have an invalid price at the moment or cannot really provide a price? What if this function reverts? And don't be fooled, like every function can revert, at the very least because of out-of-gas issues. So we always provide functions that cannot revert as soon as you give them enough ETH, and this is so-called the try functions. We have here a try read function. It returns you Boolean, whether the current value data is valid, and otherwise the value. But maybe you already worked with some oracles and you noticed, okay, like they promise to always update the oracle every, I don't know, every hour or something like this. But you do not trust them, of course. You want to do this yourself. You want to do a threshold check. So you can also, of course, get the age. That's the read with age function. And you can check, did we update the oracle in time, timely enough, or is the price fresh enough or not? And otherwise, well, then your exception handling is a difficult problem. But yeah, you can do the threshold check yourself. Just as a matter of fact, we also support the Chainlink interface, mostly. So the latest round data function, which returns this round ID and age and the value as an integer. We have this for compatibility reasons, but we went with this interface because it's battle-proven since 2017, and actually most of the data that's returned by latest round, if you ever integrated with the Chainlink data, how much of the data dictionary you actually use? Did any one of you ever check the round ID? I for sure did not that often. Just some naming conventions that we use. This is kind of important for if you just want to check out on Etherscan whether you're on the right contract or not. All our oracles are always deployed to the same address, independent of the version. For the nerds of you, we use create3 as factory for that. And we have, as naming scheme, we have the Chronicle _base_ quote. So for example, to get an ETH USD, you go to the Chronicle _ETH _USD oracle. And base quote, asset pair, I guess everyone knows this here, but if not, so base quote means if I pay with this thing, like if I want to have one of these things, how much do I need to pay in this one? So ETH USD means how much USD do I need to pay to get exactly one ETH. All of that is always verified on Etherscan, so you can easily check whether you're on the right contract. This is, of course, a manually check. For the programming check, you use the WAT function. Then there's the questions whether these oracles are actually free for all. Like, should everyone always access this oracle, or do we have some kind of permission, like some kind of whitelist for this? And a lot of oracles providers work with, like, they all have whitelists, but most of them have them deactivated at the moment because they kind of, like, there's this idea of putting them into your garden, and as soon as they start to raise prices, you're suddenly locked in already. You cannot change your provider so quickly anymore. So you basically have an asymmetric price future for yourself. We do not do this. We directly have a whitelist. We cannot disable this whitelist. We will always have this whitelist for the foreseeable future because we want to make transparent payments. We are by far the cheapest ones to update oracles from all we know. So we have competitive pricing even if we do it symmetrically directly. And for this, we got the now so-called self-kisser contract that I provided that you will need to run a function on to whitelist yourself on the oracle soon. And yeah, why is it called self-kisser? Because we have really great customer relationships. The first thing we do if you become a new customer of us is we give you a kiss. This is being we add you to the whitelist. If you don't like us anymore and go, then we so-called diss you because we de-whitelist you from the oracle. So if you want to now scan this QR code or go to this link in between there, then you will find the repo for that. There's a description on how you can just kiss yourself on any oracle that we currently have running. But there will also be the last slide will link to some like every data again. And yeah, so this allows you to get access to our oracles, and you should be ready to go for the hackathon starting tomorrow or Saturday and build some stuff. And yeah, now I had some links, and you probably didn't all manage to get them quickly enough up and running. So here's a link to an hackmd file. Up here is also the link. And there's more information about how to do now everything, even for if you're not that experienced, like how to create a new wallet, how to get Sepolia ETH, what is an RPC node, how to get connected to the Sepolia network. Sepolia network is the current Ethereum testnet. And from then on, you should be ready to hack. And if we check out this hackmd, I just want to quickly go through some stuff. So everything we do is Foundry-based. This is because it gives you a lot more nice features like fuzzing testing, differential testing, and stuff like this. We run everything of our staging currently on Sepolia, or this is where the hackathon is going to happen. So you will need some ETH for that. Infura and Alchemy provide some fossils. You get half an ETH there without signing up or anything. At least at Infura, you don't need to sign up. You need to generally have a connection to an RPC node. There's this great website called chainlist.org where you have a lot of RPC nodes where you can connect to in case you don't have an Alchemy account. And I would suggest to create a new wallet for this hackathon because you probably don't want to have this linked to your normal stuff. So if you want to create a new wallet, you can go with Cast, which is one of the tools from Foundry, and just create a new wallet and throw it away after the hackathon. Don't load any stuff up there. What oracles do we currently support? This is a little bit long. So yeah, most of the stuff that you probably want to have, all the usual BTC, USD, basically all the DeFi stuff. We even support some treasury builds like real-world assets if you have idea how we can use treasury builds on-chain in a more suitable way. An interesting one is also, of course, we have like WSTEs, so this Lido staked ETH. Maybe as a nice idea, you can do some arbitraging between like the WSTE's value that's currently provided in our case and the real value that it should have following Lido's oracle. How do you now get the access? Yeah, you basically just have to go to the self-kisser repository, one line of command, one line of like Forge script, have an RPC node set to get the Chronicle interface. Mostly you just need the read function, but it's under this link here, and you can also otherwise Forge install it. And if you want to have some more background information about how we built this constant priced oracle, or generally what kind of new cryptography we use, which was so far totally unused on Ethereum, here are some links about it. So an ETH Magician post, the docs, of course, all of this new oracle is called Scribe, and my Twitter thread for the launch, like how we did it, and what this actually means, because it solves some moral hazards also that other Oracle providers have. And I would say I just go back to this slide, and you can try to scan the QR code, get to the hackmd site, and from there on I would say you try to kiss yourself now on whatever Oracle you may want to use. And yeah, be here, ready for questions, and if you have any problems, just raise your hands. Yeah?
How would the exchange process and also who sign up? Does it change at the end of the
Yeah, okay, so repeating the question for the recording, how do the fields reach consensus? So we have a set of fields which are currently something like 22, and 13 of them, so more than 50% always, otherwise you get this 50% attack problematic. So more than 50% of them need to find consensus on one specific price. And they do it this way, that all of them fetch prices continuously from a lot of sources. Locally, on their environment, they take the median of all of this. So if you have like 10 different prices, you take the median. This makes sure that the most prices need to be wrong to influence your end result. And then they sign this median price. It again goes in the peer-to-peer network. And other feeds check, okay, what is this median price? Do I get to the same result if I take the same price data? Is it in sync with what I have? And then they either say yes or no. Hopefully they say yes. And from there, all of the feeds sign again this data via a so-called Schnorr multi-signature. And this data then, that's it, like nothing is being done with it in the peer-to-peer network, it's just flying around. But everyone who listens to the peer-to-peer network, which were the relays, they can take this finished price data, like price and timestamp data, with the signature and push it to any chain they want. Like, you don't even need to, like if you think you have some application on Arbitrum and you want to update the price there, you don't need to update it on Ethereum or on other things. Like you update it exactly where you want. And this is the kind of beauty of the open peer-to-peer network and open relay system. Everyone, like you don't have to trust us to do it, everyone can do it themselves. So yeah, basically 50% consensus, median, and again median. Yeah.
How do you register the price of a smart contract?
Like if we use a Uniswap curve, or like
So you say you fetch the price when you need it.
yeah, like you when you like when you now want to build something which integrates an Oracle, like a lending market, then you need to read the price from our smart contracts whenever you need it. Like for example, if someone wants to liquidate someone, but we as Chronicle, we don't read any price. Like we use Uniswap and this price creator, so to say, and from there we read the data. But otherwise, no data is being read from smart contracts. Any more questions, or is someone like having problems to install Foundry, get Sepolia ETH, or kiss themselves? Trust me, it makes sense to kiss themselves. It's a great thing. Or generally want to like have problems with something. Otherwise, I'm also around the next days, or you can reach me on the other profiles if you have any questions until Sunday. Okay. Or is someone maybe interested in the more cryptography stuff, like how we build the smart contract, what's kind of the interesting side effects of this, and what resolves some moral hazards that other big Oracle providers have in regards to increasing price costs and security? Someone here crypto affine? Yeah? Great. It's this QR code here, or this long, but can you scan the QR code? Do you manage that? Yeah. It should send you directly to the all information page. Okay, otherwise maybe an interesting problems that Oracle providers generally have as long as they don't offload the cost for the Oracle update to the users. So if you update the Oracle yourself, you have one specific problem, and this is you want to have all the data always signed. But on Ethereum, we basically only have ECDSA signatures. ECDSA signatures are not multi-signatures. This means if you have now 10 signers and you want to increase your security to 20 signers, boom, you suddenly have to, instead of verify 10 ECDSA signatures, suddenly you have to verify 20 signatures. Your call data load also increased by 20 times 65 bytes. So in the end, the more security guarantees Oracle provider tries to give, the higher the cost to update the oracle. And this is kind of a moral hazard because, of course, you want to provide more security, but this also means you increase your costs and you need to offload this cost to your users, and this makes you less competitive. We solved this via using Schnorr signatures, which is, if anyone is from you on Bitcoin, maybe some people still are something, Bitcoin uses Schnorr signatures. They're heavily tested. They are like from the 90s already. It's actually cryptographically proven that they are secure, which you can do with very, very few cryptographic schemes. And you can implement them on Ethereum if you are like, if you can optimize it enough. And this means you can have one signature, always the same amount of bytes, but it can be signed by 10 signers, by 100 signers, by 5,000 signers. No one cares. And this gives a really great property to our oracles and frees us from a really big moral hazard that we have. If we want to increase the amount of signers that we have, it does not increase in any way our cost. The cost to update the oracle stays the same. So if we get more feeds, we will still have the same cost to update the oracle, and we don't need to offload any further costs to the users, to you guys, because it stays constant. Yeah.
Regarding the optimistic Schnorr, it means that when you put the data object, the signature itself is not verified. Like per se, you are waiting for someone to verify if the signature is properly signed by the feeds.
Yes and no. So yeah, exactly. We have the Schnorr signature, and the problem nowadays, if you want to build one smart contract and you only want to build one smart contract for all the chains, you don't want to end up with different versions, is you have this distinction of call data cost for the gas and one-time cost for the gas. On layer 2 and basically all rollups, fuck the one-time, like that doesn't matter at all. If you have just 65 bytes of call data load, it's already 95% of the cost. Basically does not matter what you do doing one-time. So on layer 2s, on rollups where we have cheap one-time gas, we verify the Schnorr signature, that's no problem. Why is it, by the way, why is it a problem? Like, what's the step to verify a Schnorr signature is it's still just one signature, so it should be like one EC Schnorr recover or something like this. The problem is that you need to do this so-called key aggregation, like you need to do a lot of elliptic curve additions, and this increases in linear and runtime again. And this is why we do not do this on layer 1. On layer 1, we still have the constant call data size, but we do not verify the Schnorr data directly on layer 1. The Schnorr data is again signed by ECDSA, so we just sign that some feed said this Schnorr data is correct. This we do, this is constant. And then we have a really nice outsourcing, found a nice outsourcing solution again, and this is MEV. So if there's one community that's really, really good in simulating transactions and making sure to know what transactions do before they get executed, it's MEV guys, MEV people. And this is a community where which we contacted and to which we have relations in that way that we, so you push this Schnorr data on chain, we verify that it was signed by one feed, and MEV searcher, before this transaction is included, they have already simulated it a million times and simulated it off-chain, made sure that the Schnorr signature is valid. But okay, they did this, but why should they do this? Well, the thing is, we put a few ETH in all of our oracles, and as soon as you manage to find Schnorr signature that's actually invalid, you can challenge it, that's permissionless. Again, like on the whole contract, we never have any kind of message.sender check. Every function is always callable by everyone, except the whitelist functions. So this makes, basically, by utilizing the MEV community, we make sure that a big part of the people who are known for making the quickest transactions challenge this optimistic poke, this optimistic price update, before it gets basically included in the block. You can imagine this way, like as soon as we get this optimistic Schnorr data on chain, it's simulated by the MEV searchers, and if they figure out it's invalid, they will pay quite some money to be included in the same block. So you don't have, practically, you will not have a problem that there is at any point an invalid price data outside of just a single block. And then we also have, of course, a typical challenge period, we're still figuring out like what time we should use there. Probably something like 10 to 20, 50 minutes. It depends on how much frequent data you need. Like real-world assets basically is enough to push the data once per day or once per week. Other data you may want to push a lot more often. So this is a very important feature there. And maybe like generally as a way of thought, try to outsource as much as possible from your protocol. Try to do as little as possible. Use MEV. Just pay them a little bit of ETH. Make sure they can verify you. Why should you verify yourself? Let other people verify you and pay them for that. Take as little responsibility as possible. This also helps a lot, like with the regulatory problems that we currently all have, especially if you want to be a DAO. Yeah, but great questions. Someone more? Any ideas or any questions or would like to know something? Does anyone have any problems with doing anything? Is anyone trying, at least, to kiss themselves or read our oracles or understand the interface, get some Sepolia ETH? Otherwise, try to remember my face and come to me in the next days when you try it again. Yeah.
Pretty basic question. What do you think is best practice for creating test wallets?
For creating what?
Test wallets.
Test wallets. So we're talking about like Solidity-based tests, like Foundry style, or hard?
On the page you had before, there was cast new wallet.
Ah, yeah. Yeah, exactly. So how should you write Solidity tests? You mean to test your Solidity?
No. Like I've always been used to just creating an MetaMask account with no funds in it. But this is something different.
Yeah, this is something different and yet the total same thing. So in MetaMask, it's just basically created via a GUI, like graphical user interface. It's directly stored in this browser storage and stuff. And here you can, with this cast new, you can create it directly on the command line. It prints you out the address and the private key. And this is just a lot nicer if you want to use it in scripting or if you want to share the private key, which you may want to do on hackathons, but otherwise, please no. And it also creates like a real private key. If you use MetaMask, I think you always still get seed phrases, right? Which is like an encoded private key because you have these phrases. In the end, a private key is just a number. And cast new gives you this number. MetaMask, I think, still not sure, but it still gives you a seed phrase, I think. Cast this is part of this one here. So getfoundry.sh. It's a very famous nowadays Solidity development environment, or since new time also for Cairo. And it comes with a few tools. So one of them is Forge, which is to test Solidity code, compile it, deploy it. The other one is Cast. Cast is kind of the Swift knife for everything EVM related. And then there's Envil, like a local node, which is really great if you want to test stuff, like run a local node. It spins up in half a second. You can fork the state from current mainnet. Yeah, and you even get a REPL, like a read, evaluate, print loop. So like a terminal where you can input Solidity and just quickly check out, okay, what's the hash of this thing or whatever. So everyone managed to answer all the questions, and everyone who's trying managed to install everything and run some stuff? Yeah. It's in this sheet as well. The Kisser address. It arrives in the dock in a second. It should be now in the dock if you update it. Perfect. So anyone already any ideas for what to build on the hackathon? Not yet? Okay. Yeah.
What do you think are the advantages of Foundry against Hardhat?
So generally everything I'm going to say about it is probably pretty opinionated, but bear with that. So one nice thing about if you're generally a developer is to stay always in the same mindset, which most of the time means stay in the same programming language. Don't switch between programming languages so much. And this is one of the features of Foundry, that you can write your tests in Solidity. Then, of course, via doing it in Solidity, you get the whole Solidity types directly out of the box. In Hardhat or like JavaScript, TypeScript, you have a lot of times this, you need to cast something which is a little bit weird doing it in JavaScript because it does not have this kind of types normally. In Solidity, you get all the type system directly out of the box. It also provides a lot more like features for testing. For example, you can in like 2 seconds write a fast test. You just write a test function that takes an input, and this input will be randomized, so it runs basically the test 256 times by default, and every time with a different input. This is very powerful because if you test it manually via writing like 10 unit tests with different inputs, you probably test like 0, 1, type u in 256.max, and maybe -1, but do you test maybe exactly the middle one, which has this? So you have, fuzzing tests. You have also easy access to FFI, foreign function interface, so you can call other programs which are not written in Solidity and get the result into your Solidity code. This is very useful. For example, we use this a lot for Scribe. We basically wrote the whole backend, like the Schnorr signature creation in Solidity. And when the backend team started to develop it as well, we could just call the backend code to say, hey, produce me a Schnorr signature. We used our Solidity code and tested whether it produces the same output. This is called differential testing or differential fuzzing. That's also a powerful feature. You have fork tests. Like you can write a test which directly forks mainnet or optimism mainnet or testnet, also at specific blocks. And then you can prank being an address. So if you, for example, want to play around with what would be if there's now 10 billion byte pressure on Uniswap in this specific pool for USDC, you can fork the current state, prank being some Uniswap, USDC whale, or the USDC minter even, mint like 10 billion of USDC, execute the trade, and you know exactly what happens in that case. Yeah, those are one of the nice tests. You also have invariant testing. So invariance is generally like try to come up with as many invariants when you write your code. So invariance is like mathematical properties that should always be true. Most famous example in DeFi is the Uniswap x times y equals k. That's an invariant. Whenever you call Uniswap, this invariant is true, except in between state transitions. And you can test this easily via Foundry in that you just say test underscore invariant. And then it tries it with even more, like it's basically, again, randomized testing. It gives you random inputs, but it keeps the state. So it basically calls Uniswap like 1 million transactions with 1 million time random trades and checks, okay, does every time when we finish the execution of this Uniswap trade, this invariant, was it correct or not? Yeah, then there are like those arguments, of course, it's written in Rust and blazingly fast and stuff, but I mean, via IR, we have compilation times that suck anyway, so. Yeah. So I'm going to check when I'm out of this room how many kisses we got. So if someone managed or going to try, continue. You missed the best parts. We're now at the awkwardly silent part of the presentation. Should I start again? Yeah? Oh, I'm happy to do that. Let's see how much time we have left. Okay, a fast one. So welcome to the Oracle workshop. We are Chronicle, redefining ubiquitous access to verifiable data. First, a little bit to my person, I'm Pascal, or also Merkleplant. Basically, Google Merkleplant, you will find the contacts, and don't hesitate to reach out if you've got any questions or something. Who are we? We are the longest living Oracle on Ethereum, because we launched with MakerDAO in 2017. Before being Chronicle, we had the very sexy name of MakerDAO Oracle Core Unit, but soon we're going to launch publicly. So yeah, we spinned off of MakerDAO, and we're going to be a normal public Oracle provider. Our keywords are basically verifiable. So everything that happens from someone fetches data from Coinbase or Kraken or any kind of source provider up to data lands on chain, everything in between is is cryptographically signed, and you can check it yourself, either technically via listening to the peer-to-peer network or via our website, where you can do the ECDSA signature verification. We are community powered, so we don't actually run any of the infrastructure that we write ourselves, which is sometimes a little bit disappointing because you write all the code but you never get to execute it. But other people are doing this, and these other people are heavily invested entities in our whole Ethereum ecosystem, which you basically more or less trust anyway already. Like, for example, we got the Infura, and you probably use MetaMask, so you trust Infura more or less already. You hopefully have some kind of Gnosis safe. Gnosis is one of our feeds, so you have some trust in them already. Maybe you trade via 0x aggregator or on DYDX. They are also part of our feed. So these are all entities that do not have a financial stake in not being malicious, not a direct, but more of a reputation stake. Like, if we would prove that DYDX does some shit in our Oracle system, they would use far more than just being kicked off. Like, they would use all the reputation of being a reasonable community, a reasonable entity in our community. Gitcoin is another example. We are pretty decentralized generally. Like, MakerDAO is longest running DAO, and everything we currently are possible. Like, we don't have any multisig. We only have MakerDAO governance. They are the only ones who can update anything in our oracles. We are blockchain agnostic. So what we do on chain is just one simple signature verification check. Otherwise, the backend does not even know the data lands in the end on Ethereum. For them, it could also land just in an SQL database from BlackRock or on Solana. So this gives us quite some flexibility, and we are cost efficient. Like, we don't offload the price via pull oracles to users. We update the price ourselves. We make sure that the price will be updated, and we have constant price for the cost for the price updates. So if we add more signers to our price data, like, let's say it's signed by 10 different people, say this price is correct, and then we want to increase it and say, no, wait, we want to increase the security, we want 20 signers to have this, to sign this price. It does not affect our cost to update the oracle. Normally in everything blockchain related, you most of the time nearly have linear increase of cost. In our case, it's everything constant. Small overview, we got here the sources, like all the different things where price is created, like Coinbase, Kraken, Uniswap, Curve, Balancer. We also have real-world assets like Treasury and for MakerDAO. So this would be then like there we fetch data from BlackRock, for example. And this data is fetched by everyone who's our feed. So like, yeah, all of these guys. And they exchange the data continuously. signed, and you can check every single signature from that. They take the median from this data, they send this around, this median value is again signed by everyone, and as soon as you get this data, this one signed price of a median of which is signed by everyone, then you can pick up this data from the peer-to-peer network, which is open, like you can literally do this, and push it on-chain. And it does not matter on which blockchain you push it, it does not matter on which chain, like it's just a signature and the price. And as long as we have some elliptic curve possibility to execute on a chain, we can verify the signature. Yeah, and this relay is currently mostly run by MakerDAO and other of the feeds of the feed entities. Our interface is pretty simple because we try to make it as hard as possible for our customers to fuck themselves, like to shoot themselves in the foot. It's called Chronicle, very intuitive. We have basically the function read. It returns you an unsigned integer value. It uses 18 decimals. Everything uses 18 decimals. We are on Ethereum, like 18 decimals is the normal precision. So you read the data, you get the price. That's basically it. Problem is sometimes like every oracle can revert. Function can always revert. So we also, and sometimes this is ugly because if you use this try-catch mechanic from Solidity, it's kind of, it makes the code quite ugly. So we also provide functions which are not able to revert as long as you give them enough gas, and they are always prefixed with a try. So we have like the try read function, and it returns you a bool and the value, and this bool tells you whether you can trust this value or not, or whether we think you can trust this value. And maybe you don't think, okay, just because we say we trust this value, you trust this value, because you want to have a price frequency, like you want to have the timestamp from the value, and you don't trust any value if it's older than 10 minutes, no matter what. So we also have functions read with age and the corresponding try read with age that also returns the age, so the timestamp of the value. And if you don't trust any value that's older than some specific threshold, then you can revert or do something else. So we give you the possibility to check it yourself. We also provide chain link compatibility, so this latest round data function, that's the usual one. We make sure we return in some cases, like for the round ID, for example, a constant, and some values we needed to adjust because Oracle, like Chainlink, does not return unsigned integer, they return integer, so you have some overflow problematic maybe. We make sure in that implementation that we have that all of this data is either correctly converted or we revert directly, and we make sure that if you hopefully follow the Chainlink tutorial and how to make sure that your data is correct, like the threshold check, the round ID check, stuff like this, that all of these checks will always pass. So if you have now a very well smart contract that does all the Chainlink checks, it will check with our, it will work with our oracles as well. Yeah, naming convention is actually not that. So we have a naming convention, Chronicle _ base asset _ quote asset, which means if you have any kind of oracle, if you use our oracle, it will look something like this as the name. Base and quote asset, so the asset pair basically means how much do I need to pay in this thing to get one of these things. It's the price of ETH and USD. Interesting side fact, why do we have this _1 here? Because we use deterministic address deployment via create3, and there we always need to have a specific salt. If you're there we always need to have a specific salt, and this _1 just makes sure that we can deploy more than one time a Chronicle _ETH _USD. It's just a counter. This gives some nice features so that, like this create3 functionality, that you can create different contracts with different bytecode to the same address, which is not possible via create, because there you are only depending on the nonce, and also not possible via create2, because there you're depending on the bytecode. And if you just change a single line of your bytecode, you cannot use create2 anymore. So we use the combination of both of them called create3. No. So metamorphic contracts, no, we don't use metamorphic contracts. For everyone who does not know, these are contracts that can self-destruct themselves, so basically delete themselves, and then you can redeploy anyway to the same address. So this is like the ultimate ruggability contract, and it's going to be deprecated soon. So it would not be future-proof anymore. And We also don't use any proxies. So this is not behind any proxy. This is the real contract. We don't use any proxies. We could provide it for you as a customer if you really want to for some whatever reasons, but we believe in immutability like MakerDAO always did. MakerDAO does not have a single proxy, like does not use proxies. We don't use proxies. This is just about the factory. Where do we deploy contracts? Because one common security issue, as simple and stupid as it sounds, is you copy paste the wrong address and send it to a different chain, and suddenly your money is gone. Even like Wintermute, one of the biggest market makers, got hacked like this recently. That they deployed a Gnosis safe on mainnet, had one address. They deployed a Gnosis safe on Optimism. They got another address. Someone sent the money, used the mainnet address, but sent it on Optimism, and a lot of money was gone. We don't want to run into this problem, so this is why we make sure that we, like the whole address is only derived from this string here. If we want to deploy to the same address, we just have to use this same string. It does not matter who's the like we have the factory, so this needs to be at the same address. But otherwise, it does not matter what the bytecode is, what the contract is. It does not matter what nonce we have. The only thing that matters is this string, which will be translated into a byte 32 into a salt. Yeah. Exactly. So we will have for every contract always the same address on different chains. And this is like not so much used for whatever reason, this create 3, because it, like you can say you can do this via create 2 too. And this is true if you do all the deployments on all the same chains at the same time. But if we now deploy on Avalanche, Ethereum, Optimism, all of those chains, and in 2 years a new rollup comes out, also EVM compatible, up until then, we maybe have changed like our Oracle contract, we maybe have updated it or whatever. This means the bytecode changes, this means the address will be different no matter what. So to be, like it's easy to deploy everything to the same address if you do it in one moment. It's hard to make it future-proof so that in 10 years you can still deploy to the same address. Highly recommend checking out Create 3. It's Solady and Soulmate repository, or in our case, like we have a tool, it's called Greenhouse. That's our factory, like we plant the contracts in our greenhouse. And it was initially created by 0x, this DEX aggregator, which is also one of our feeds. Perfect. Good. What time do we have? Yeah, I think it's fine to finish 5 minutes earlier, even though I hate to break your enthusiasm. But thank you very much.